Data from this video will be available very soon. In the meantime, any data that you might be interested in, you can obtain from this website. Link below in description. Hello guys, and welcome to this video. Thank you for finding time to watch it. This video is just the beginning of the ALIAS modeling tutorial series. In this video we are modeling a car that is very close to me, the McLaren 765 LT. I was very privileged to be a member of the digital modeling team at McLaren Technological Center. I want to take you into a journey of digital modeling of this car. By watching this series of the videos, you will be able to look over my shoulder and see the whole process of digital modeling of this car. You will get an insight into what was happening, what was going on during the design, including the technical and engineering requirements, also the fabrication requirements, and as well as design requirements. Hopefully, I will be able to show you how to win the battle against engineers and everyone around you, because when you are a digital modeler, sometimes you find yourself feeling alone and fighting a battle against all the people who just come over at your desk and tell you different stories of something that can't be done. So if you want to be a successful digital modeler, you have to persevere. You have to very often surprise even yourself. We are going to be using the ALIAS software with the latest extension of the subdivision modeling, subdivision polygonal modeling, and afterwards we are going to move on to the more traditional method of A-class surfacing using NURBS. In this first part of the video, we are going to focus on a front bumper and splitter. So without any further ado, let's jump right in. Alright, so here is the original data of the McLaren 720. Let's just turn on the subdivision mode, and as you can see, there's a whole range of tools for the polygonal modeling. In this tutorial we are going to be using at least some of them, so you will have an opportunity to see how they work. At the same time, I'm going to arrange all these side windows so that they better fit my user interface, and you will obviously be able to see them. Also, you can set them to automatically hide, so when you are not hovering around these windows, they will just scroll in. Now, I think I will start by modeling this nose of the front bumper. I will begin modeling by creating a curve. Now the curve is being created just like normally we do in ALIAS. There's no magic to it. And we can go slightly outboard because the new bumper of the 765 LT is slightly proud of the original bumper. I'm using the transform CV tool just to better adjust my CVs. At the moment I'm kind of playing with these shapes. This is the very initial stage of the project, so I'm just playing around and see what works, what doesn't work. What I want to do is to keep my panels tangent. Basically, what I'm trying to do is create one curve across the bumper and the splitter. In this original data, bumper and splitter are not tangent. There's a kink in the middle, as you can see. but during the modeling of 765 the two separate panels were at least tangent, so they don't look like they don't belong to each other. Okay, so I have split this curve in the location where the bumper and splitters begin. I think my curve is almost ready, at least for the initial stage of modeling, and I can move on and start creating some geometry, some planes. I'm going to use the extrude tool just to quickly create some surfaces. So basically what I'm doing now, I'm just grabbing this curve and I'm extruding it in Y direction. Later I will chop up this patch into small patches, but at the moment I just want to make sure that the whole patch is tangent around the center. I want this patch to be tangent when I take this patch and mirror to the other side. I want the center area to be tangent. Otherwise, if I move this hole in X direction, I will be left off with a kink in the middle. I think it's time to chop up this patch. We're going to keep this first hole in the place where it is without moving it. We want to keep the tangency across the center, but then we can add more holes, and we can just play with the other holes just to better match our shape. We can use the new subdivision tool called transform. Basically you have this manipulator popping up. You can do with this anything you want. You can scale, you can rotate, you can move it. I'm adding more holes because I know I need more complicated shape, and I grab edge loop and I'm trying to sculpt something nice, keeping in mind that I have to stick to the original shape of the bumper as well. I cannot go too deep, I cannot go, basically I cannot just let my imagination drive me to somewhere that I will be lost. I am basically grabbing the holes and I'm trying to sculpt a form that is going to be a little bit more closely related to the original bumper. I can use either the new transform tool, or I can use the tool that has been with Alias, that we had in Alias forever, which is called the Transform CV. Each of the tool has got its advantages, and you can basically choose whichever you prefer. At the moment I'm using the Transform CV tools, basically because I can very easily choose mouse sensitivity, and I can be very precise with my movements if I want to. So I actually prefer the Transform CV tool over the new Subdivision Transform tool. Okay, we are pretty close to the scan. Just make sure that CVs are looking nice, looking even from every angle. If you want, you can slide the CVs responsible for the tangency across the center. Just make sure that you grab two CVs at the same time, and this way you wouldn't lose the tangency across. Yeah, so here is where our bumper splits up where the bonnet begins. I think we are okay on the top area. Now we are going to decide where the split line between bumper and the splitter is. So basically we are going to create another hole and slide it towards the location we want it to be. You basically need to consult your pictures. You have to apply your artistic license just to make sure that this split panel is in the right place. You can look at the pictures as many times as you like, and obviously you can, at this stage of the design, you can change your mind as well. Sometimes you feel like your proportions are correct, and very often after a while you just realize that proportions could be better. So basically what I'm trying to say is there's never too late to change. I'm deleting the bottom patch of this surface, and I'm still consulting, eyeballing the picture. And what I'm doing now is actually I'm still sliding the edge loop, the bottom edge loop down, until I'm happy with the result. Now, next step is to create this crease. So basically, we are going to pick up this edge loop and create the extrude. Move it in X direction and in Z direction. So this is going to be our first crease. You can change the display of your model, and in this mode you can see exactly where the crease is. Make sure you have a crease in the right spot. Later on we can add more holes around the crease just to better control the round. And the same rule applies with the other crease. So basically the other crease will be just here, and then from here we are picking up the loop edge and extend our loop edge just to create another patch. Yeah, just make sure that CVs are distributed correctly, there's no dips. You can consult the photograph as many times as you like. Make sure that the splitter is long enough. This is kind of important because it will determine the overall length of the car. Okay, I think I'm happy with that at the moment. I still keep in mind that I can always go back and change it if I need to. I think now it's time to move on to the next bit and create geometry around the headlamp. Grab the single edge of this square and use the extension tool with the normal option on. It is basically like sliding, so you are creating new geometry normal to the existing patch, existing edge. By clicking a space button, you are ready to create another one. And then you can click space button again, and then this way you can create another one, and you can play like this all day and create as many patches, as many segments of this patch as you need. Again, transform tool, just make sure that our new geometry is close to the original data. The 765 LT doesn't have new headlamp. It has a little bit changed outline of the headlamp, but the headlamp itself is exactly the same. Later I will be explaining exactly what has changed in the outline of this headlamp, but at the moment I know that I should just keep my newly built geometry close to the original data. I think I forgot to look at the geometry from the top view. Yeah, so I need to move it in X direction. Basically make it wider in X direction. I pull the CVs until they reach the end of the bumper and the beginning of the bodywork. Now in the Z direction I move all the CVs, all the relevant CVs up. Everything goes up a little bit, and I basically, as usual, I'm trying to stay close to the data, making sure that I don't deviate too much from the gray model. Now this time I'm sliding. Sliding is also very good if you are very close to the model and you don't want to deviate too much when manipulating. You can just slide. This way you will be sure that sliding doesn't destroy the job that you have done so far, and sliding wouldn't basically change everything. When using a polygonal modeling, you will find yourself very often playing with CVs. At this moment you basically focus on creating a good volume, basically a model with good volume, with good proportions. Highlights at this stage are really not important. And basically, once you grasp the principle of building and manipulating these kind of surfaces, you can basically create everything. And also because you're not wondering and worrying about highlights and all the technical stuff, you just let your brain fully focus on design, which is also very cool, I think. When using NURBS for modeling, many times I find myself that I'm not focusing on what I'm doing, I focus on how to do things. And when I do that, my design very often suffers because I'm not creative. So because in this polygonal modeling you basically push and pull CVs or edges, you can fully concentrate on the shape, on the design, which is kind of cool, I think. And it's not only in ALIAS polygonal modeling module, also in any other polygonal software you find yourself doing exactly the same. Right, so we are almost done with the top area of the headlamp. I think there is still a little bit of discrepancy, but given the time we should be able to complete everything very quickly. If we were to use NURBS method to create this area, it could take us even one or 2 days, I think. I think that after ALIAS introduced the sub-polygonal modeling, software like Maya or Modo are not necessary to have anymore. Basically, you have all you need in one package. If you consider the price of the cheapest ALIAS concept, I think with the new subdivision polygonal modeling module, I think it could be a good deal. It could be a deal to consider, because you also get a huge, immensely powerful tool that before wasn't available to us. Okay, so you can see that I'm still using this transform tool. I'm picking the edge, I'm moving the edge in the direction I like. I can rotate, I can scale, and I'm slowly moving on. I'm trying to keep my CVs perpendicular. It's not always possible, but if there is a chance of achieving a better CV layout, I will go for it, and I will take my time just to make it just a touch better. If you keep on this attitude, you will end up with something very good, and very soon you will get used to being more precise, and you apply this precision to any model and any job you are in charge. And this way your life will be much easier, because there won't be people coming at your desk and telling you that something is not precise enough or it's not good enough. Just take your time and do things right, and you'll be okay. This area will benefit if we add one more degree, and then after that we can add some curvature to the surface. And also make sure that the CVs look okay from every angle. And make sure that our geometry stays close to the original data. You can do sliding, you can do directional movement. Yeah, you can give it just a touch of curvature in here. Otherwise we will end up with the surface that is really too flat. Now one more look at the CVs, and I can see that there's a lot of wobbliness going on. So I think I will grab CVs or edge loops and you know, work on just to make everything just a little bit better. Now in this view the CVs are not really good, so I'm going to pick them and do what I have to do to make everything better. I'm doing the mixture of sliding and modification in Y direction. Like this CV is standing too proud, and these two can benefit from sliding. There you go, much better. Now in this top area, those CVs are hovering in the air, so I have to push them in. And maybe this one out a little bit. I think that in general our geometry looks okay. Now we're going to focus on the panel split and make sure that the location of this panel split is spot on. So basically we are going to eyeball the images that we have. And I decided to slide this hole a little bit up, and this hole would be our location for the panel split. In the meantime, I can delete all of the redundant holes and make my geometry as simple as possible. I'm pushing the CVs in X direction. By doing so, I'm not affecting the shape in the front view. Okay, so let's pick up the edge loop and carry on our extrusion. Maybe the normal function is better in this case, so we can actually slide our holes and create a little bit more accurate geometry. Okay, let's try it again. Sometimes you find yourself that you click on something that you didn't intend to, and but it's not a big deal. I mean, you can always start again. Okay, so we are happy in the front view. Now we're going to move our CVs in X direction. So we only affect a side view and the top view without making any modifications to the front. If your geometry is diving too much inboard, just simply pull it out. Now in this place I can see that we are probably missing one degree, so we are going to add one. But before we do that, we are going to create geometry on this side. So basically just extrude one edge. We can temporarily unweld the geometry and move the CVs of one patch to the location we want. We are going to be building a gap between the patches, and afterwards between the gap we are going to create an additional patch. Unwelding tool is actually very cool because you can basically detach any patches you want anytime you need. If you pick up this CV, you can basically move it to the place you want. And then if you pick up the edges of each of the patches, you can create a bridge between. And this way you can create an extra patch, which is going to work pretty fine because it's four-sided patch. Obviously you still need to tweak it and arrange it so that it looks better. Alright, I think we are okay with the area around the air intake. We can save the data, and we also can move to the other side of the headlamp. Just one more thing before we move on. I just need to, just as usual, play a little bit with these CVs just to make them a little bit better, and then we can move on. As you can see, the CVs are zigzagging, so just I'm trying to make them better. And also the last CVs have to be pushed in quite a bit. Just try to finish one side before you move on to the other one. And I think we probably would need to add one extra degree in between this this patch because we don't have enough control, and we need to just pick up this edge and pull it out a little bit, with maybe some sliding necessary as well. Okay, now we are moving on to the bottom lip of the front air intake. Before we start creating more geometry, let's just arrange the edge of this patch just to make it more perpendicular. And when it's ready, we can just keep on creating more geometry. As usual, use the extend tool. Maybe in this case we can just use the global settings, or maybe not, maybe just use the normal settings. We can slide. We probably need 2 or 3 patches, and we just need to scale it out a little bit. And now let's think about how we can connect these edges to the existing geometry. Try to use the tool weld and match one edge to the other. I think we need an extra degree on the top patch. Okay, let's just weld this left side first and see how our CVs are lining up. Now we can unweld this area first, because we know this is where the panel split is going to be. Quick consulting with the photograph. And let's just arrange the CVs so we can create a nice looking lip. In the meantime, let's just add 1 extra degree in this patch, so we have edge available for us to perform the welding. After welding, as usual, let's do some tweaking. I think sliding in this case would be the most beneficial. Again, don't forget to look at your model from different angles just to see if there is any need for improvement. As you can see, these CVs are kind of wobbly, so we need to move them around again in X direction. If you do that, you are not changing the profile in the front view. I think I pushed the CVs too much, so I'm going to undo. I'm going to undo what I've just done, and instead of pushing those CVs in, I'm going to push out the other side. Remember that this is the split panel location. Remember that if you see some areas that need improvement, always improve, always change, always tweak, never leave it for later. Okay, one more look at the photograph, and I think our panel split needs to move a little bit. Sliding tool would be great for this job. I think somewhere here is fine. And then let's just grab the top edge loop and do the same. Slide it down. And then we can weld. We can weld one side to the other. When we welded them up, we can then later on split them again by doing the unweld. There you go. So here we are. We have our split location kind of certain, and we are not going to touch it anymore. I think we can move on to the air intake lip. I hope you can see that our car is taking shape. Again, at this point, the speed of modeling is quite important, so it's not that crucial to be, 1 millimeter accurate. If you feel that design is good, just carry on. You can always change it later. If you're not sure, remember that this is a very simple volumetric model and can be changed later on. Okay, I'm kind of happy with the result. I think we can just add a little bit more of geometry. So we're going to use the tool cut. We're going to add 1 more degree along the lip. And then when we have that 1 more degree, we can carry on sculpting. At the same time, try to avoid any triangular patches. If you have any triangular patches, you can always use the tool weld. And weld tool works very well on edges, but also works on CVs. So you can pick up one CV, weld one to the other. Alright, so here is the first part of our video. Thank you for watching. I hope you liked it. Please subscribe and look forward for the next video. Take care and see you soon.